Hi, my name is David Wyban, and I'm an applications engineer here at Keithley Instruments. I'd like to show you the pulse measurement capabilities of the new Keithley Series 2280S Precision Measurement DC power supplies. With the new Series 2280S, you can accurately measure current pulses as small as 140 microseconds, small enough for accurately characterizing the sporadic current draws associated with today's wireless and mobile devices and chips. In this demonstration, I'm going to measure the current draw of an 802.15.4 wireless module during a wireless transmission. This diagram illustrates the test system setup. The Series 2280S power supply provides power to the wireless device and measures its current draw. The device itself is controlled using a USB to SPI controller. Digital I/O pins on the USB to SPI controller are used to trigger the wireless device to start its transmission, and are simultaneously used to trigger the Model 2280S to make a measurement. The entire test system is controlled by a custom test program running on the PC. Finally, a Tektronix MDO4104B mixed domain oscilloscope will be used for visualization and verification of the measurements being made. This test program automates the process of configuring the wireless module and configuring the Series 2280S power supply for making fast pulse current measurements. Using this program, we will make 10 current measurements over 10 separate transmissions and get back the data. To start, I simply click the Run button and watch as the test is performed and data is returned. Looking at the collected data, I can see the average current draw of the wireless module during transmission was approximately 16.3 milliamps, and the graph shows very little variation in the current draw from each transmission. Next, let's take a look at the scope to verify our measurements. Looking at the screen of the Tektronix MDO4104B, we can see three traces. The purple trace at the top is the current flowing into the wireless module. The yellow trace in the middle is the trigger signal that starts the transmission and triggers the Series 2280S power supply to measure. The blue trace at the bottom is the meter complete signal from the Series 2280S, indicating that its measurement is complete and it's ready for another trigger. Looking at the purple line, we can clearly see 10 separate current pulses, each with a corresponding trigger pulse in yellow and a meter complete pulse in blue. Using the on-screen cursors, we can see that the current matches what was measured by the Model 2280S power supply at about 16.3 milliamps. If we zoom in on one of the pulses, we can see how the purple current pulse from the transmission closely follows the yellow trigger signal. In the lower half of the screen, we can see the RF spectrum measured during the transmission, verifying that the device transmitted. As we scroll the window off the current pulse, we can see how the spectrum goes flat, verifying that the transmission is ended. I hope this video has given you a good idea of the measurement capabilities of the new Keithley Series 2280S Precision Measurement DC power supplies. Power supplies have long been a necessity for functional testing of electronic devices and chips, but due to limited speed and accuracy, have often been overlooked for use in characterizing a device's power consumption. The Keithley Series 2280S provides you with the clean and accurate power needed for functional testing, as well as the ability to accurately characterize a device's power consumption as well. Thank you for watching.